Hey everybody! The purpose of this video is to get you some solutions to your exponential regression quiz. I know there was quite a bit of randomness involved in this one. You guys had to use your own birthday to store to your randomizer to get some nice random numbers out. I'm going to go ahead and use my example that I ran before for you guys. So you'll definitely obviously have different values than me for your 5 points. And some of this is, so there's going to be some similarity and some difference in the quizzes because of that. Add your data point to the TI scatter plot near right. So here I've set the window up looking like this, and I've got my data over here in my TI, so I will go ahead and set up a scatter plot, turn it on. This all looks good. And then I'll set the window to the same one that I set for you guys, because why not? And then we got -1 up to 35, because we started at 30, right? And 5, and we're going to hit graph. There it is. Whoops. Sorry. Still got the last quiz's data turned on there. There's my graph right there. There's my scatter plot. And you guys are going to look similar-ish. It'll look different. Next thing I tell you to do is try to fit an exponential model. Now, it makes sense that it should be exponential because of the discussions we had in class. So regardless if you remember that or not, we can try to fit the exponential model. I'm saying it's 0 expreg. We're going to go ahead and store it to y1, and we're going to hit enter, and it's going to say error domain crud. What happens and why? And you probably remember that the reason this happens is you have to go back in. You can't ever have a y value of 0 with an exponential regression. You can't have that. You got to delete that out. It doesn't like zeroing because it knows you can't get to 0. If you try it again, boom, there's your model right then. My model comes out to be y equals, looks like 24.3 times about 0.85 to the x power. I'll make that superscript so it looks a little bit happier. I'll make it nice and bold. We'll make it larger so it stands out. There's my model right there. There's my model right there. It says, could you have come up with the perfect regression model? I want to come back to this. And yes, the answer is yes, we could have. This is an extra point now. We know from our discussions in class, the number out front here should be, ideally, the number of people in the experiment at the beginning, which in our case was 30. Okay? The percentage that's here should be the percentage remaining after each of the X trials. So ours is 85%, meaning we're losing 15% each time. But we shouldn't have lost 15%. We should have lost closer to 17% because the percentage remaining should have been 5/6, which is about 83%. We're not bad with our data. It's not as good as it could have been ideally. So this is actually the perfect model where you're shooting for that extra point, 5/6 to the x power, because you're going to leave 5/6 behind if you keep rolling until you get, and I have forgotten, until you get threes. Until you get threes. There's a 5/6 chance you won't get threes. And then just to satisfy my curiosity, I will graph that right here. 30 times 5/6 to the x power. I press graph, boom, and you see how close, if I turn the plot off, you'll see how close the two models are. Boom, boom. I mean, they're beautiful. A little bit noisy in the beginning, but they fall into line pretty nicely. The next extra point is, suppose the experiment was roll the dice until 3 or 4 come up. What would be the perfect regression model? Well, 3 or 4 means you're losing 1/3 of the results. So the equation would look very similar. Except this should be 2/3 because you're losing 2/6 or 1/3 each time, which means you're leaving 4/6 behind. One thing I should have clarified up here, though X and the Y and what they mean. X is the number of trials that you've run, and Y is how many that are remaining. Now it's kind of redundant to say that because we define that back here. So hopefully you understood the implied in this is the definition of what the X and the Y are. So there's your exponential regression quiz. We'll have some more coming up in the future. I've got some more fun data from chicken laying expectancies to world population figures to all kinds of good stuff. So we will see a little bit of all that in future quizzes. Hope it helped.